Now, let's start with the theorem again. This time, we have a theorem exclusively for triangles, which says that if two triangles lie on the same base and between the same parallels, then they are equal in area. That is, if you can see in this figure, we have two triangles ABC and BCD, which lie on the same base BC and between the same parallels AD and BC. So, from this theorem, we can state that area of triangle ABC is equal to area of the triangle DBC. Now, for proving this, I will draw a line parallel to BC and also a line parallel to AB. Let me name it E and F. So, if you can notice here, we have two parallelograms ABCF and EBCD here. Now let's focus on the parallelogram ABCF and the triangle ABC. You notice both of them lie on the same base BC and between the same parallels AF and BC. So, from the theorem that we learned in the previous video, we can assert that area of the triangle ABC is equal to half of area of the parallelogram ABCD. And if now we just look at the parallelogram EBCD and the triangle BCD, we would again find that both these figures lie on the same base BC and between the same parallels ED and BC. Hence, we can say that area of triangle BCD is equal to half of area of the parallelogram EBCD. Now look carefully at the two parallelograms ABCF and EBCD. Both of them lie on the same base BC and between the same parallels AD and BC. Hence, we can say that area of both these parallelograms are also equal. That is, area of parallelogram ABCD is equal to area of parallelogram EBCD. Now, if area of both these are equal, then from these three equations, these two are equal. That means if these two are equal, then these two should also be equal. That is, area of triangle ABC would be equal to area of triangle BCD. Hence, we have proved that if two triangles lie on the same base and between the same parallels, then their areas are equal. Now let's solve an example in which we have to prove that the diagonals of a parallelogram divided into four triangles of equal area. That means if we have a parallelogram ABCD whose diagonals intersect at O, then we need to prove that area of the triangle AOB is equal to area of the triangle OBC is equal to area of the triangle OCD is also equal to the area of the triangle BOA. Hence, we need to prove that the area of these four triangles are equal. So, for proving this, let's first look at the triangles ADC and the triangle DBC. Both of them are lying on the base DC and also between the parallels AB and DC. So from the previous theorem we can say that area of triangle ADC would be equal to area of the triangle BDC. Now look carefully. What are these two triangles made of, ADC and BDC? They are made up of AOD plus DOC, that is triangle ADC. And for BDC, it is made up of triangle BOC plus triangle ODC. That means in both these triangles, the portion ODC is common. Now, if from both these triangles ADC and BCD, if I remove the common portion that will have equal areas for both the portions BOC, then again the leftover portions should also have equal areas. That means area of triangle AOD, which is the leftover portion of ADC after removing DOC, would be equal to area of triangle BOC, which is the leftover portion of triangle BCD after removing the area of triangle BOC. Hence, we have proved these two triangles to be equal. Now what about these two? But before that, we can say that if the triangles AOD and BOC have equal area, then by similarity, area of the triangle AOB should be equal to area of the triangle DOC. That means if these two triangles which are opposite to each other have equal areas, then these two triangles which are also opposite to each other should also have equal areas. Again by the same logic. That means I will consider the triangles ADB and ACB which will have equal areas, and then I'll remove the portion AOB, and the leftover portions would also have equal areas. So I'll say that area of triangle AOB would be equal to area of triangle DOC. Now for the triangle ADB, if I draw a line from A which is perpendicular to DB, that line would act as the height of the triangle ADB. Now by that height I mean that this point, if I name this point E, AE is perpendicular to DB. That means AE is the height of the triangle ADB. Similarly, AE will also be the height of the triangle ADO and also of the triangle AOB. That means triangle ADO and triangle AOB have the same height, AE. And if you remember, in a parallelogram, the diagonals bisect each other. So we can also say that DO would be equal to OB. Now if DO is equal to OB and AE is common in both, then area of triangle AOD is equal to half into AE into OD, and area of the triangle AOB is equal to half of AE into OB. And here we have said that DO is equal to OB. If these two are equal and AE is common, then both of these areas will also be equal. That is, area of triangle AOD would be equal to area of the triangle AOB. Now, area of this triangle is equal to this triangle, and area of this triangle is equal to this triangle. Then area of this triangle will also be equal to this triangle. That means these three triangles will have the same area. And again, area of this triangle is equal to this triangle. Now if this and this have the same area, then actually all four of them will have the same area. Hence we have proved that in a parallelogram, the diagonals divide it into four equal triangles. That means triangles having equal areas. Now let's move on to our next question. Here we have a triangle ABC and AE is the median passing through A. That is BE is equal to EC. And we have to prove that the median divides the triangle into two triangles having equal areas. That is, area of triangle ABE should be equal to area of triangle AEC. Now, if AE is the median, then we know that BE would be equal to EC. And we have AD to be perpendicular to BC. That is, AD is the height of the triangle ABC. Also, AD would be the height of the triangle ABE. Similarly, AD will also act as the height of the triangle AEC. That means height of these two triangles are equal. And now, if I write the area of the triangle ABE is going to be half into AD, which is the height, into BE. And if I write the area of the triangle ADC, it is going to be half into the height AD into its base EC. Now here BE is equal to AC. If BE is equal to EC and AD is the common height, then these areas are equal. That means area of triangle ABC is equal to area of the triangle ADC. Hence it has been proved that a median divides the triangle into two smaller triangles having the equal areas.